You think water is wet. You've felt it 10,000 times. On your hands, your face, in rain. It clings. It soaks. It feels wet. But here's the truth. Water does not feel like anything. Water has no sensation. The wetness you experience when you dip your finger into a glass is not a property of the water at all. It is a phantom constructed entirely inside you, and the mechanism behind it, the real reason you feel wet, was hidden in plain sight until a sunny afternoon in 1827, when a botanist in London looked through a microscope at pollen grains dancing in water and accidentally discovered that everything you touch is trying to punch you. The question we must answer is this: if water itself has no wetness, what exactly is your skin feeling? Let us start with what seems obvious. You touch water, you feel wet. Simple, but now I ask you, what does wet mean? Not the word. The sensation. Close your eyes and imagine it. Wetness feels cool. It feels like something spreading. It feels slippery, clinging, persistent. But here's the problem. Water is just molecules. Billions of them, yes. But each one is simply two hydrogen atoms stuck to one oxygen atom. A water molecule does not know it is wet. It does not cling with intent. It does not cool you on purpose. It just is. So where does that feeling come from? Most people, if you ask them, will say something like this: well, water touches my skin, so I feel it. Wrong. Or at least incomplete, because your skin is not a smooth surface. Under a microscope, your skin looks like a landscape of hills and valleys, covered in a thin layer of oils and dead cells. When water lands on it, the water does not simply touch you. It collides with you. Thousands of molecules per second, each one moving, each one jostling. And this is where the story begins. In 1827, Robert Brown was studying pollen grains suspended in water. He expected them to sit still. They did not. They jittered. They danced. Tiny, erratic, endless motion. He thought at first it was life, some vital force in the pollen. But when he tested dust, ash, even fragments of glass, they all did the same thing. The jitter was not life. It was something else, something universal. It took nearly 80 years for the answer to become clear. I worked on it myself in 1905. The pollen was not moving on its own. It was being pushed by water molecules, not gently, violently, constantly, from every direction. Water, you see, is never still. Even in a glass sitting on a table, every molecule is vibrating, spinning, colliding with its neighbors millions of times per second. This is what we call Brownian motion, the proof that matter is not solid and stable, but restless, a storm at the smallest scale. Now let us return to your finger in the glass. You think the water is calm. It is not. The water molecules are hammering your skin. Thousands of impacts every fraction of a second, from every angle. Your skin cannot feel individual molecules, of course. You are far too large for that. But your nerves can feel the aggregate, the sum of all those collisions. It registers as pressure, as texture, as coolness, because those molecules are also stealing energy from your skin with every hit, carrying heat away. This is not wetness as a property of water. This is wetness as an effect of molecular bombardment. But here is where it becomes strange. If wetness is just molecules hitting you, then why does water feel different from air? Air molecules hit you too, millions of times per second. You are sitting in a room right now, and the air is pounding your skin just as violently as water would. Yet you do not feel wet. You do not feel much of anything. Why not? The answer lies in how many molecules are hitting you, and how closely they are packed. In air, molecules are spread out, far apart, with empty space between them. In water, they are crammed together, almost touching. When you dip your finger into water, the number of collisions per second jumps by roughly a factor of 1,000. Your nerves, which ignore the steady hum of air, suddenly detect a surge, a new pattern. And your brain, which has learned since birth to associate this pattern with liquids, labels it wet. So wetness is not in the water. It is not even on your skin. It is in the difference. The contrast between the quiet bombardment of air and the storm of liquid molecules. And that difference, that contrast only exists because matter is not continuous. It is made of pieces. Tiny, jittering, violent pieces that never stop moving. Now you might think we have solved it. Wetness is molecular collisions. Done. But no, because if that is all it is, then we should be able to predict exactly how wet something feels just by counting molecules. We cannot. There is something else happening, something deeper, and it has to do with the way water molecules pull on each other even as they push on you. Water molecules do not just collide, they also grip. Not with hands, of course, but with something almost as stubborn electric charge. Every water molecule is slightly lopsided. The oxygen atom pulls electrons toward itself, leaving the hydrogen side a bit positive and the oxygen side a bit negative. This makes each molecule a tiny magnet. Not a strong one, but strong enough. When billions of them are packed together, they tug on each other, align, and form a loose network. This is why water beads up on a leaf. Why it forms droplets. Why it climbs up a paper towel against gravity. The water is holding on to itself. And this changes everything about how wetness works. Because when you put your finger into water, you are not just being hit by molecules. You are breaking that network. You are pulling molecules away from each other. And they resist. They cling to their neighbors even as they coat your skin. This is why water does not bounce off you like air does. It spreads. It lingers. It soaks in. The wetness you feel is not just impact, it is invasion. Water molecules are crawling into the microscopic valleys of your skin, displacing air, surrounding each ridge and hair and pore, and your nerves feel this as persistence, as something that will not let go. Let me give you a test you can imagine. Take two identical metal spheres, both at room temperature. Dip one in water, leave the other in air. Now touch them both. The wet one feels colder, much colder. Why? Same metal, same starting temperature. The difference is the water. Those clinging molecules are not just sitting there. They're evaporating, jumping off the surface one by one as they gain enough energy to break free from their neighbors. And every time a molecule evaporates, it steals heat from the metal. From your skin, this is evaporation cooling, and it is brutal. Water can pull heat away from you hundreds of times faster than air can. So the wetness you feel is also a thermal signal. A drain, a loss. Now here is where Robert Brown's jittering pollen comes back. Because Brownian motion is not just a curiosity, it is a measurement tool. The faster the jitter, the hotter the liquid. The slower, the cooler. And this means that the temperature of water, the average energy of all those molecular collisions, directly controls how wet it feels. Cold water feels sharper, more biting, because the molecules are moving slower but packed even tighter. Hot water feels softer, more enveloping, because the molecules are faster, more chaotic, and the network is looser. Same substance, different sensation, all because of motion at a scale you cannot see. I want you to imagine something now. Imagine you could shrink down, become smaller than a skin cell, smaller than a bacterium, small enough to see individual water molecules around you. What would you see? Not a calm blue liquid. You would see a storm, molecules spinning, tumbling, smashing into each other and into you. You would see clusters forming and breaking apart in fractions of a second. You would see molecules leaping off the surface into the air and air molecules diving in to take their place. There is no stillness, no equilibrium, just endless, violent rearrangement. And every sensation you have ever called wetness is your body's way of telling you you are inside the storm now. But we are still missing something. Because if wetness is just molecules hitting and gripping, then oil should feel exactly like water. Oil molecules also collide. They also cling to each other. They also spread on your skin, yet oil feels different, slicker, less wet somehow. Why? The answer is not in the molecules themselves, it is in how they interact with you. Water molecules are polar, lopsided, remember. Your skin is covered in polar molecules too, proteins, salts, sugars. Water recognizes them. It binds to them. It pulls them slightly, tugs at them, forms weak temporary bonds. Oil molecules are not polar. They are symmetric, smooth, indifferent. They slide past your skin without grabbing. So even though oil spreads just as well as water, it does not stick the same way. Your nerves detect this, and your brain labels it differently. Wetness, then, is not one thing. It is a blend, impact, persistence, thermal drain, chemical grip, all happening at once, all coded into a single sensation that feels so simple you never question it. But peel it apart, and every layer reveals motion. Molecules that never stop, forces that never rest. This is what I mean when I say water does not feel wet. Water does not feel anything. You feel the consequences of what water is always doing. And now we must go one step further, because so far we have talked about what happens when water touches you. But what about when it does not? What about the air around you right now? You think it is dry. You think it is empty. It is not. Every breath you take, every room you sit in is full of water. Not liquid water. Water vapor. Invisible molecules floating free among the nitrogen and oxygen. And these molecules, these invisible passengers, change how wet everything feels, even when nothing is visibly wet. When humidity is high, the air is crowded with water vapor. When you sweat, your skin releases moisture, hoping it will evaporate and cool you. But if the air is already saturated, there is nowhere for that moisture to go. It sits on your skin. It clings. You feel sticky, oppressive, wet, even though you are not underwater. The sensation is real. But it is not because water is touching you from outside. It is because water is failing to leave you. The evaporation has stalled. The thermal drain has stopped. And your body, which relies on that drain to regulate temperature, starts to panic. This is why a hot day at 90% humidity feels unbearable, while the same temperature in a desert feels merely warm. Same air temperature, different water content, different wetness. Your sensation of wet is not just about liquid. It is about the balance between liquid and vapor, between arrival and escape. You are always standing at the edge of a phase transition, and your nerves are reporting which way the molecules are flowing. So ask yourself now, when you say something is wet, what are you really feeling? You are feeling molecular collisions, evaporation, electric tugging, thermal loss, the failure of air to absorb more vapor, all of it tangled together, processed by nerves that have no idea what a molecule is, translated into a single word your ancestors invented long before anyone knew matter was made of pieces. And yet the word works. It points to something real, something your body has always known, even if your mind did not. But if that is all true, if wetness is just physics at the molecular scale, then why does it feel so certain? Why does water feel undeniably, obviously wet, when everything I have just told you says wetness is a constructed interpretation, not an inherent property? Now here is the part nobody tells you. The certainty you feel, that absolute conviction that water is wet, is not coming from the water. It is coming from your brain's refusal to show you the truth. Your brain is not a camera. It is not recording reality and playing it back to you. It is a prediction machine, and it has been trained since infancy to expect that certain patterns of nerve signals mean liquid. When those signals arrive, your brain does not wait to analyze them. It does not check the data carefully. It simply runs the pattern through a model it built years ago and hands you a conclusion. Wet. Instant. Automatic. Unshakable. But that conclusion is a guess. A very good guess. Refined by millions of years of evolution and a lifetime of experience, but still a guess. and we can prove it is a guess by breaking the pattern. Here is an experiment you can try, though I do not recommend it. Take your hand and place it in water cold enough to numb the skin, just above freezing. Hold it there until your fingers go dull. Now pull your hand out and touch something dry, like wood or cloth. For a few seconds it will feel wet, not damp. Wet. Your brain is receiving confused signals. Temperature drop, pressure, sluggish nerve response. It matches the pattern to liquid and insists you are touching water, even though you are not. The wetness is a hallucination, a phantom built from incomplete data. Your skin knows the truth, but your brain has already decided. This tells us something uncomfortable. The wetness you feel is not a direct readout of physical reality. It is your brain's interpretation of molecular events, filtered through models that prioritize speed over accuracy. And those models can be fooled. They can be tricked. They can disagree with the molecules themselves. So when you ask, why does water feel wet? You are really asking two questions. First, what are the molecules doing? We have answered that. They are colliding, gripping, evaporating, stealing heat. Second, why does my brain call that wetness? And the answer is because calling it wetness kept your ancestors alive. Think about it. If you could not detect water quickly and reliably, you would die. You would drink from poisoned puddles. You would fail to notice when your skin was freezing. You would not know when to seek shade or when to find shelter. The animals that survived were the ones whose brains became obsessed with water, so sensitive to it that they could feel a single drop on the back of the neck and spin around in alarm. That sensitivity is still in you. It is why a tiny splash feels so intrusive. Why you cannot ignore a wet sock. Why even the idea of wetness, right now as I say the word, makes you hyper-aware of moisture on your skin. Your brain is not neutral. It is biased toward water, and it will construct the sensation of wetness from the faintest excuse. But here is the deeper problem. If your brain is constructing wetness, then where does the construction end? Is temperature real, or is that constructed too? What about color? Sound? Pain? The answer, which I spent much of my life circling around, is this. All sensations are constructions. None of them exist in the molecules. The molecules have no color, no sound, no wetness. They have position, motion, charge, mass, everything else. Everything you feel is your brain's way of summarizing molecular behavior into signals you can act on. The universe does not care if you call water wet. The universe does not even know you exist. Wetness is a translation, a map. And like all maps, it leaves things out. Now let us return to those jittering pollen grains. When I calculated the motion in 1905, I was not just proving that atoms existed. I was proving that you could predict the invisible by watching the visible. You could take the random walk of a pollen grain, measure it carefully, and work backward to find the size and speed of water molecules. This was shocking at the time. It meant that sensations like wetness were not mysterious. There were consequences. You could trace them back. You could explain them. And once you explain them, you could control them. This is why we can now make materials that water cannot wet. Superhydrophobic surfaces, we call them, coat a surface with tiny spikes at just the right scale, and water will bead up and roll off like mercury. The molecules still collide. They still try to grip. But the geometry defeats them. There is too much air trapped in the gaps. The water never makes full contact. It never invades. And so, even though the water is touching the surface does not feel wet. If that surface had nerves, it would report dry. The molecules have not changed. The forces have not changed. Only the structure has changed. And structure, it turns out, is enough to flip the sensation. We can go further. We can make materials that feel wet when they are completely dry. Hydrogels, for instance. Polymers that trap water molecules in a network so tight the water cannot flow, cannot evaporate, cannot escape. Touch a hydrogel and it feels wet, cold, slippery, but there is no liquid water on the surface. The molecules are locked in place. What you are feeling is the shape of the network, the way it deforms under your finger, the way it detects heat. Your brain reads this as wetness. It is wrong. But it has no other category, so it guesses, and you believe the guess. Do you see what this means? Wetness is not a switch. It is not binary. It is a spectrum, a gradient, and where you draw the line between wet and dry is arbitrary. Your brain draws it one place. A beetle's brain draws it somewhere else. A sensor in a smartphone draws it somewhere else again. There is no universal answer. There is only molecular behavior and the tools we use to measure it. And yet, and this is important, the behavior itself is real. The collisions are real. The evaporation is real. Brownian motion is real. We can predict it, measure it, film it with the right equipment. We can write down the mathematics and calculate exactly how fast a pollen grain will jitter in water at 20 degrees Celsius. The predictions match the experiments to absurd precision. So even though wetness is a construct, it is a construct about something. It points to events that happen whether you feel them or not. Your brain is guessing, yes. But it is guessing about a world that does not care about your guesses, and somehow, improbably, the guesses work. This is the tension at the heart of all perception. The universe is made of particles that have no sensation. You are made of particles that produce nothing but sensation. Somewhere in between, there is a bridge, a mapping, a code, and every time you feel something wet, you are using that code without knowing it. You are translating the storm of molecules into a single, simple signal. You are collapsing 1,000 dimensions of motion into one dimension of feeling. And you do it so fast, so automatically, that it feels like no translation at all. It feels like truth, but it is not truth. It is useful. And useful, in the end, is all biology ever cared about. So when you touch water and feel wetness, what is really happening? The molecules are hitting you. You are interpreting the hits. The interpretation is fast, reliable, and totally invented, and none of that makes the water any less real. Let us go back to the beginning. You dip your finger into a glass of water. You feel wet. We started with a simple question, why? And now, after everything, the answer is this. You feel wet because billions of invisible particles are striking your skin in a pattern your brain learned to recognize before you could speak. The water is not wet. The wetness is not in the molecules. It is in the gap. The space between what the molecules are doing and what your nerves tell you they are doing. And that gap, that translation, is where all of human experience lives. But here is what makes it strange. We can predict every part of this. We can calculate how fast water molecules move at a given temperature. We can measure how many collisions happen per second. We can model the hydrogen bonds, the evaporation rate, the heat transfer. We can even predict how your nerves will respond, which signals will fire, which pathways in your brain will light up. The mathematics works. The experiments confirm it, and yet nowhere in those equations is there a variable for what it feels like. We can describe wetness completely without ever explaining why wetness feels like anything at all. This is not a failure of physics. It is a boundary. Physics tells you what happens. It does not tell you what happening is from the inside. And I do not know if it ever will. We can predict it, map it, control it. But we cannot fully explain why molecular collisions become experience, why motion becomes sensation, why the universe, which has no feelings, produces beings that do nothing but feel. Some people find this disturbing. I find it beautiful, because it means that every time you touch water, you are participating in something unexplained, not mysterious in a mystical sense. We know the mechanisms. But mysterious in a deeper sense, the mystery of why there is something it is like to be you. Why the storm of molecules does not just happen in darkness, unwitnessed, but appears to you as coolness, as pressure, as wetness. That appearance is the most ordinary thing in your life. And it is also the most extraordinary. Now think about what this means for everything else you feel. Warmth, pain, softness, hunger, every single one is the same kind of translation. Molecules doing what molecules do, and your brain constructing a sensation to summarize it. You have never touched anything directly. You have only ever felt your brain's interpretation of electric forces between atoms. You have never seen an object, only the light it reflects, filtered through cells and processed into color. You have never heard a sound, only pressure waves turned into signals. Everything you call reality is a model, a beautiful, functional, necessary illusion built on top of particles that know nothing and feel nothing. And yet the particles are real. This is not solipsism. This is not everything is in your head. The water exists whether you touch it or not. The molecules collide whether you feel them or not. Brownian motion happened for billions of years before any brain existed to notice it. The universe does not need your sensations to keep running. But your sensations need the universe. They are about the universe. They are your translation of it. Imperfect, compressed, delayed, but still tethered to something outside you. Remember those pollen grains jittering under Robert Brown's microscope? He saw motion with no visible cause. It looked random, chaotic, meaningless. But it was not meaningless. It was the signature of an invisible reality. Molecules, atoms, the kinetic theory of heat. The jitter was a message. And once we learned to read it, we could see deeper. We could measure the size of atoms, the temperature of the sun, the age of the universe, all from watching tiny grains dance in water. Your sensation of wetness is the same kind of message. It looks simple, immediate, obvious. But trace it down and it opens into a cosmos, molecules that never rest, forces that stretch across emptiness, a brain that builds worlds from electrical sparks. And beneath all of that, a question we still cannot answer. Why does any of this feel like something? I cannot give you the final answer. No one can. But I can tell you this. The fact that you feel wetness means you are not separate from the molecular storm. You are part of it. Every atom in your body was forged in a star. Every water molecule you have ever touched has been in a cloud, in an ocean, in a dinosaur, in another person. The boundary between you and the water is not a wall. It is a conversation. Molecules leaving you, molecules joining you, energy flowing back and forth. You think you are touching the water. Really, you are exchanging pieces of yourself with it. And the sensation you call wetness is just your nervous system noticing the exchange. So here is the thesis you cannot unhear. Water does not feel wet because wetness is not a property of water. Wetness is what it feels like when your brain notices that matter is made of restless, colliding pieces and that you are made of the same pieces, dancing the same dance. You are not observing the storm. You are inside it. You always have been. And every time you feel something wet, you are feeling the truth of what you are. Not a solid thing touching another solid thing, but a temporary pattern of atoms recognizing its own nature.